Let's work a problem involving projectile motion. At the top of a 40-meter cliff overlooking the valley floor below, an object is propelled forward and upward, excuse me, at an angle of 30 degrees relative to the horizontal line. The firing speed is 100 meters per second. Travels up and to the right and eventually strikes the valley floor below. What we wish to know is how far from the edge of the cliff, call that distance x, does the projectile land? Well, we begin with this equation. The horizontal distance traveled in a time t of a projectile is equal to the x component of the initial velocity. The x component of the velocity in projectile motion doesn't change, so whatever it once was, it will always be. Question is, what is v naught x? Well, this is the v naught vector. That's the horizontal or x direction. The shadow that this arrow casts on the x-axis is cast on the positive side of the x-axis, and it has whatever this length is, the base width, which is the hypotenuse times the cosine of 30. So this is 100 cos 30 degrees times the amount of time t it takes to go from the top of the cliff to the valley floor. So everything hinges on our being able to determine the value of t. Let me show you how we'll find t. The equation, which is the companion of this one, the one that allows us to determine the y coordinate in the future of a particle undergoing projectile motion, is this: v naught y times t minus 1/2 g t squared. Now, we're looking for that amount of time t that needs to go by until the y coordinate of our projectile corresponds to that point there. You may recall that in all of our studies of the motion of a single object, wherever the object begins its motion, or at least wherever the object is when we first begin looking at it, that's where the 0 reference mark is. And so the y coordinate of this point right there, where the motion begins, is 0. Now, below that point, we're looking at y coordinates that are negative. At that point there, the y coordinate is negative 40 meters. Same thing as that. And so the y value that we're looking at there is negative 40. Now let's look at the right side of this equation. V naught y is positive 100 sine 30. And then we multiply times the as yet unknown time it takes to fly from that point at the top of the cliff to the valley floor. Continuing, this is negative 4.9 t squared. I'll have to remind you that g is 9.8 meters per second per second. Well, this equation involves only one unknown, it's t. And it's a quadratic equation, but you don't need to know it's a quadratic equation unless you would like to solve this equation using the quadratic formula. I would prefer to use my equation solver to find that value, so give me a moment. I'm back. value of t, that's the solution to this equation, is 10.59 seconds. Have that backwards. It's 10.95 seconds. Well, now we have the last piece of the puzzle, the value of t that we put right there to solve for x. I'll do that here. X equals 100 cos 30 times 10.95. Final result, I'll calculate for you. $948.30. Final answer. If you have any questions about anything I've done in this video lecture or any of the other video lectures, or questions about what you see in the chapter notes, you can email me and I'll try to help you as soon as possible.